Welcome to this video all about primes, factors and multiples. You'll find the full PDF, all the questions, clues and solutions on mathsupgrade.co.uk. These questions are all non-calculator questions. It starts with question 1, which is worth 3 marks. We're given a list of numbers. We need to write down 3 different prime numbers that add to make 20. So I'm just going to start off by listing the first few primes, which are here. And then I'm just going to identify the prime numbers in the list. I need to just find 3 of them that add to give 20. So that can either be 2, 5 and 13, or alternatively 2, 7 and 11. You don't need to write down both of these, you just need to write down one of them. That's 3 marks for that question. In question 2, we're asked to write down 3 different factors of 18 that add to give a prime number. So remember that factors are numbers that can divide into that number. So here's the factors of 18, and I've written them in pairs here. So 1 and 18, 2 and 9, 3 and 6. These multiplied to give 18. Now I need to write down 3 of these that add to give a prime number. Remember, here are some prime numbers at the top here. So I can either have 2, 3 and 6, which adds to give 11, or 2, 3 and 18, which adds to give 23, 1, 3 and 9, which adds to give 13, or 2, 6 and 9, which adds to give 17. So any one of these would give you 2 marks. Question 3. Nida writes down 2 different primes. She adds together her 2 numbers. Her answer is a square number less than 30. So first of all, let's write down some of the square numbers that are less than 30. So that's 1, 4, 9, 16 and 25. These are numbers that can be exactly square rooted to give a whole number. So now I need to write down 2 prime numbers that she could have written down that add up to give one of these. So here are some answers you could have. So I could have 2 and 7, that adds to give that square number there. 2 and 23 are both prime, that adds to give that square number there. 3 and 13 are both prime, that add to give that square number there. Or 5 and 11 are both prime, and they add to give that square number there. So any one of these would give you 2 marks. Question 4, for 2 marks, we need to write 56 as a product of its prime factors. So we need to break down 56 into its factors and identify which one of those are primes, and then multiply them together. That's what product means. So here's 56. I'm going to split it up into 2 different factors, not including the number itself. So I've chosen 8 and 7. There are lots of ways you can do this. This is just my method. So 8 and 7. So I know that 7 is prime, so I'm going to circle that. And then 8 is not prime, so I can break it up again. So 2 and 4. 2 is prime. 4 isn't prime, so I'm going to break it up again. And 2 times 2. These are both prime. So now, all the prime numbers, I'm just going to multiply together, and that should give me 56. And I'm going to write that down. So 56 equals 2 times 2, which is 4, times 2, which is 8, and 8 times 7 is 56. So it's correct, and that's 2 marks for that question. Question 5. I need to write down 180 as a product of its prime factors, same as question 4. So I'm going to break down 180 into 2 factors, not including 180. So I've chosen 20 and 9. 9 is not prime, so I'm going to break it down into 3 times 3. They're both prime numbers. 20, I'm going to break down into 10 and 2. 2 is prime. And 10, break down into 2 and 5, and they're both prime. Then I need to write down 180 as a product, so multiplying its prime factors together. So multiplying these numbers that I've circled. 180 is 2 times 2 times 3 times 3 times 5. I've done it in order from smallest to biggest, but you can do it in any order you want for this question. So let's just check this. 2 times 2 is 4, times 3 is 12, times 3 is 36, 36 times 5 is 180. So that question is definitely correct. That's 3 marks. In question 6, same as question 4 and 5, I'm going to express 36 as a product of its prime factors. So I'm going to break it down into factors, and I've chosen 4 and 9. 4 I can break down into 2 and 2, which are both prime, so I'm circling them. 9 is the same as 3 times 3, I'm circling those. And then I'm just going to multiply all the primes together. So 36 is equal to 2 times 2 times 3 times 3. Let's just check this mentally. 2 times 2 is 4, 4 times 3 is 12, 12 times 3 is 36. So that works for 2 marks. Question 7, similar with the last few questions, I need to write 525 as a product of its prime factors. So this number is a little bit larger now. So I just need to think about how I can break it down. I break it down using 25, since I know that this is in the 25 times table. So do 525 divided by 25. You can use short division, and that will give you 21. 25 is a square number, so I can break it down into its square roots, which is 5. So 5 times 5 is 25, and they're both prime. 21 is the same as 7 times 3, and they're both prime. And then I can write it as 525 equals 3 times 5 times 5 times 7. Again, I've done it from the smallest prime to the biggest prime, but it's up to you how you do it, since the question doesn't have a preference. And that's 3 marks. Question 8. We need to write 168 as a product of its prime factors for the first 3 marks. So as with the last few questions, I'm going to break it down into its factors. I know it's an even number, so I'm going to start with 2. 168 divided by 2 is 84. You can use short division if you're not sure about that. 2 is prime, I'm circling that. 84, I can break into 12 and 7. 7 is prime. 12 is the same as 4 times 3. 3 is prime. And 4 is the same as 2 times 2, and they're both prime. Writing it as a product, so writing it as a multiplying of its prime factors, and that's 168. In part B, I need to find the highest common factor of 168 and 180. Well, first of all, I'm going to write 180 as a product of its primes. So I've written that here. 180 is the same as 3 times 3 times 2 times 5 times 2. What I'm now going to do is going to use a Venn diagram. Venn diagram is the best method for this, since both numbers are quite large numbers. So in this Venn diagram, in this region here, I've got all the factors of all the prime factors of 168. In this region here, I've got all the prime factors of 180, which I've got from this diagram. Now in the middle are the prime factors which are of both numbers. So I can see in the middle I've got 2, 2 and 3. If I multiply these together, just these 3 numbers here, I'll get the HCF, the highest common factor, of 168 and 180, and that is 12. The whole question there was worth 5 marks. In question 9, I'm told that Matt and Dan cycle around a cycle track. Each lap Matt cycles takes him 50 seconds. Each lap that Dan cycles takes him 80 seconds. They both start cycling at the same time at the start line. We need to work out how many laps they'll have cycled when they're next at that start line together. So, since I know each lap that Matt takes is 50 seconds, right, I can then recognize that after 50 seconds he'll have done 1 lap, after 100 seconds he'll have done another lap, and then 150 seconds he'll have done a 3rd lap, and so on and so forth. If I start listing those numbers, I can recognize that they're actually multiples. So I'm writing the multiples of 50. In the same way, Dan will be at the start line after 80 seconds, after 160 seconds, and so on and so forth. So I'm writing the multiples of 80. Now, when will they next be at the start line together? Since they start at the same time, I can just look for a number which is in both lists, a time which is in both lists. So you can see 400 is in both lists. That's the lowest number that's in both lists. So in essence, I found the lowest number that's in both multiple lists. It's the lowest common multiple, and that's 400 seconds. 400 seconds represents 8 laps for Matt, you can just count down that list, and 5 laps for Dan, just counting that list. So that is the answer here. Matt has done 8 laps, Dan has done 5 laps, and they're both at the start line together. And that's 3. In question 10, we're told that buses to Ashby leave a bus station every 24 minutes. Buses to Barford leave the same bus station every 20 minutes. A bus to Ashby and a bus to Barford both leave the bus station at 7:30 in the morning. When will a bus to Ashby and a bus to Barford next leave the bus station at the same time? So, as with question 9, this question also involves lowest common multiples. I know that Ashby and Barford, the buses leave at the same time. Okay, so I can start listing the times when they both leave the bus station. So they both leave the bus station at 0 minutes. Then they leave from Ashby 24 minutes later, then another 24 minutes and another 24 minutes. So I'm writing here the multiples of 24. From Barford, they leave after 20 minutes, and then another 20 minutes, and another 20 minutes. So that's multiples of 20. So I need to find the lowest common multiple of 24 and 20. Looking down both lists, I can see the lowest number that's in both lists is 120. Now I need to write down the actual time they leave. So it's no good just writing 120. It's no good just even converting into hours. I then need to write that as the actual time. So since it was 7:30 at the start, 2 hours later will be 9:30 AM, and that's 3 marks. In question 11, I'm told that Liz buys packs of coloured buttons. There's 8 red buttons in each pack of red buttons. There's 6 silver buttons, and there's 5 gold buttons in each of their packs. Liz buys equal numbers of red, silver and gold buttons. How many packets of each colours of buttons does she buy? For 3 marks. So with this question here, it's essentially a question about finding the LCM of 8, 6 and 5. To find the LCM, you can either list the multiples of 8, 6 and 5 like I did with question 10, or I'm doing it here as a Venn diagram. So I'm breaking down 8 into its prime factors. I've listed those in that region there, and then silver, and then gold. Now to find the LCM from a Venn diagram, you multiply all the numbers together in the Venn diagram. So I'm going to multiply 2 times 2 times 2 times 3 times 5. That gives me 120. So the LCM is 120. So she needs 120 buttons. But the question asks us how many packs of each buttons does she buy. Since red buttons comes in packs of 8, if I do 120 divided by 8, I get the number of packs, and that's 15. Similarly with silver and similarly with gold. So I'll get 15, 20 and 24 for 3 marks. In question 12, we're told that Rita's going to make some cheeseburgers for a party. She buys some packs of cheese slices and some boxes of burgers. We're told there's 20 cheese slices in each pack and 12 burgers in each box. She buys exactly the same numbers of cheese slices and burgers. We need to work out how many packs of cheese slices and how many boxes of burgers she buys. This question involves the lowest common multiple of 20 and 12. That tells us how many cheese slices she needs to buy and how many burgers she needs to buy. We then need to convert that into the packs and the boxes. So to find LCM, I'm doing it using prime factors and the Venn diagram, but you can do it just listing the multiples of 20 and the multiples of 12 and seeing which is the smallest number that's in both lists. The smallest number in both lists is 60. I've got that by multiplying 5 with 2 and 2 and 3. So I need 60 cheese slices and 60 burgers. In terms of the packs of cheese slices, that'll be 60 divided by 20, which gives me 3 packs of cheese slices, and 60 divided by 12, which gives me 5 boxes of burgers. Part 2 is very similar to what I've just done. I just need to convert this back into the number of bread rolls. Since we've already ascertained here she needs to make 60 burgers altogether, then she'll need 60 bread rolls. The whole question was 4 marks. Question 13. We're told that Caroline is making some table decorations. Each decoration is made from a candle and a holder. Caroline buys some candles and some holders, each in packs. There's 30 candles in a pack of candles, and there's 18 holders in a pack of holders. She buys exactly the same numbers of candles and holders. How many packs of candles and holders does she buy? So, as with the last few questions, this involves lowest common multiples again. I need to find the lowest common multiple of 30 and 18. You can do that just by listing the multiples of 30 and 18 and seeing which is the smallest. I've done it here using prime factors. So the prime factors of 30 are 2, 3 and 5. Prime factors of 18 are 2, 3 and 3. And so the lowest common multiple is gained by multiplying all of these numbers in these entire regions together. That gives me 90. So the LCM is 90. Now to find the packs of candles, since it's 30 in each pack, I'm going to do 90 divided by 30, which is 3. And to find the packs of holders, since there's 18 holders in each pack, I'm going to do 90 divided by 18, which gives me 5. The second part we've basically already done. We're asked how many table decorations does she make. We already worked that out here in terms of 90, so that is the answer there. And the whole question there is worth 5 marks. In question 14, we're told that Vina bought some food for a barbecue. She's going to make some hot dogs. She needs a bread roll and a sausage for each hot dog. We're told there's 40 bread rolls in a pack and 24 sausages in a pack. And we're told that she bought exactly the same number of bread rolls and sausages. We need to work out how many packs of bread rolls and how many packs of sausages she bought. This question involves lowest common multiple again. I can either do that by listing the multiples of 40 and 24 and finding the lowest in both lists, or I can do it using prime factors. I've done it here using prime factors. So if I multiply all these prime factors together, I get 120, which is the LCM. Now to work out the packs of bread rolls, there's 40 in each pack, so 120 divided by 40 gives me 3. And packs of sausages, there's 24 in each pack, so 120 divided by 24 gives me 5. The second part of the question I've already really answered here. There's 120 hot dogs that she can make. The whole question was worth 5 marks. Question 15. We're told that Shelley sells books. On Saturday she's going to give a free bookmark and a free dust cover with each book that she sells. All the books are the same size. She needs to buy the bookmarks and the dust covers. We're told the bookmarks come in boxes of 24, dust covers come in packs of 36. She wants to have enough bookmarks and dust covers for 250 books. So this is a new part here, a new content for this question here. So this is critical. She buys exactly the same number of bookmarks and dust covers. Work out the number of bookmarks and the number of dust covers she buys. So in this question here, I need to find the LCM of 24 and 36. But the difference here is that it's got to be at least 250. So if the LCM is less than 250, then we're not interested in it. So to find the LCM, I'm using a Venn diagram of the prime factors of 24 and prime factors of 36. That gives me the LCM as being 72. The problem is 72 is not at least 250. So I need to find now the multiples of 72. So I can have 72 times 1, 72 times 2, 72 times 3, 72 times 4. 72 times 4 is definitely bigger than 250. So this is the number of bookmarks and dust covers that I need to buy. To convert this into boxes of bookmarks, I can divide by the number of bookmarks in each box. So 288 divided by 24 gives me 12 boxes. Similarly, 288 divided by 36 gives me 8 packs of dust covers. And that was 4 marks for that question. Question 16 is worth 3 marks. It's the last question in the booklet and it's also the hardest. We're told that Miss Paisley is organising games for children in her class. She's going to put the children into teams. If she puts children into teams of 4, so multiples of 4, there'll always be 2 children left out. If she puts children into teams of 5, so multiples of 5, there'll be 3 children left out. We need to work out the smallest possible number of children in her class. Essentially, we need to find the multiples of 4 plus 2 and the multiples of 5 plus 3. What that is are these numbers here. Let's just look at what this means. So this first row here, I've got one team of 4 and I've got 2 children left out. That means I've got 6 children altogether. I've got 2 teams of 4 and 2 children left out. That means I'll have 10 children. So if I just continue that sequence downwards, I'll get the numbers 6, 10, 14, 18, 22 and 24. And I can carry it on. For teams of 5, similarly, if I have one team of 5 and 3 children left out, I'll have 8 children altogether. 2 teams of 5 with 3 children left over, I'll get 13. And so on and so forth. So essentially, I can continue this sequence down here. And you can see the lowest number that's in both lists is 18. That represents the smallest possible number of children in her class. The smallest number that's in both of those lists. That is 3 marks. Thanks for watching this video.